good morning to everyone. So in our last video, we have seen about the prediction of points, about the four quadrants, what is the position of points in all the four quadrants, and we also discussed what the corresponding quadrants for these four positions. Okay. Now in this video, we will be seeing about the solution for all these four problems. Okay. So what I have did is I have just separated, drawn the quadrants individually. Okay, so if you can see, this is our first quadrant. Okay, so we have seen the quadrant in 2D format. So I have just taken the first quadrant and drawn it. Okay, this is our first quadrant. This is our HP, VP, XY. So the position will be above HP and in front of VP. So if you see in second quadrant, the position will be above HP and behind VP. If you see in the third quadrant, position is below HP and behind VP. You see in our fourth quadrant, the position is below HP and in front of VP. Okay, let's see the first question. So we have already seen our last video. It comes in first quadrant. Okay, so a point A is 40 mm above HP and 20 mm in front of VP. So above HP and in front. So we can assure it comes in first quadrant. Okay, so let's see first quadrant. Okay, so this is our first quadrant. Okay, so I am going to, what is the position? A point A is 40 mm above HP. So this is HP and above I am going to give a point. A point is A. A point is A. So it is 40 mm above HP. It is 40 mm above HP. A point A is 40 mm from the horizontal plane. Okay, and it is 20 mm in front of VP. So the point, this point is this point is 20 mm. Okay, if you can see, this point is 20 mm in front of VP. So we have positioned the point. Okay. So now what happens is, so here we are going to there is a solution. So to get the solution, we have to draw and check it. Okay. So 40 mm above HP and 20 mm in front of VP. So just see, just imagine. Okay, where the shadow of the point will fall. So just imagine. Okay, from here I am going to see. From here I am going to see the front view of a point. Okay, so just you can imagine I am going to pass a torchlight or something in the front view of a point. Where the shadow will fall, where the shadow of the point will fall, the shadow will be falling here. The front view will be falling here. Okay, so what is the distance from the center axis? So from here to this point, the distance is 40. So the front view is 40 because you have seen the front view of a point. Okay, the front view of a point is projected in VP. Okay, so you can imagine we are going to pass a torchlight. Okay, the shadow of this point will be falling in the vertical plane. So the front view will be in the vertical plane. What is the distance from the center axis? The distance of the point from here to here is 40. The same 40 mm. Okay, okay. We have, let's draw the front view. So from here we will draw a 40 mm line and then give a point. Okay, so the point is A dash. So why I am putting dash here? It is because to identify it as a front view. Whenever you are going to identify as a front view, you have to put a dash. So it is A dash. A point is A. So if it's a front view, it is A dash. So if you have wrote A dash here, it means it is a front view. So A dash. Okay. So this is the front view. What is the distance? Draw the extension line, draw the dimension line. The extension line should have at least 1 mm gap from the point. Okay. Draw arrowheads. Arrows is very important. Arrow should be in the ratio of 3:1 mm. Arrow should be the ratio of 3:1 mm. Okay. So distance is 40 mm. Okay. So now we are going to put the top view. So where the top view will fall. So I am going to just imagine I am going to put the light from here. Where the top view of point will fall. The top view will fall here. The shadow of top view will appear in the horizontal plane. Okay. So what is the distance of the point from the center axis? From here to here, the distance is around 20 mm. Okay. So if you put a point, the point will be, the front view will be put in horizontal vertical plane and top view will be put in the horizontal plane. Okay. So what is the distance? It is 20 mm. So what is the general condition is HP rotates clockwise 90 degree. HP rotates clockwise 90 degree. I'll just show the demonstration. Okay, if you see, this is our first quadrant. Okay, so this is our HP and this is our vertical plane. So a point is, okay, imagine a point. Okay, imagine a point is 40 mm above HP and 20 mm in front of VP. This is VP and this is HP. Okay, a point is here. So what happens? Front view is projected in vertical plane and top view is projected in horizontal plane. Okay. So now what is our condition? HP will be rotated 90 degree clockwise. Okay. So what happens? This point is projected here. Is at a distance of 20 mm. The point is at a distance of 20 mm from the center. So now we are going to tilt the horizontal plane clockwise direction. We are going to turn the HP 90 degree clockwise direction. So our point will be here. Okay. So we can draw this. Sorry. So this is our point. This is our top view. So write as A. Just A. It should be exact 20 mm. It should be exact 20 mm. Use a scale and draw exact 20 mm. Okay. So this is our point. It should have distance of exact 20 mm. So mark it as A. Because since it's a top view, I just give a name as A. It's a front view. We have to mark it as A dash. Okay. So what is the distance? Just draw an extension line. So this is 20. Top view is 20. So this is our solution for question number 1. Okay. So now let us discuss about the question number 2. Point B is 50 mm above HP and 30 mm behind BP. Okay. So it is second quadrant. It comes under second quadrant. We can able to see here. This is our second quadrant. Okay. So a point is 50 mm above HP. It is a point. It is named as B. A point B. It is 50 mm above HP. It is 50 mm above HP and 30 mm behind BP. 30 mm behind BP. So above HP and behind BP is the question. So it comes in second quadrant. So this is the point B, 50 mm above HP and 30 mm behind BP. Okay. So now what we are going to do? Again we are going to project the front view. Again we are going to project the front view. Okay. Again we are going to project the front view. So we can assume the front view will be projected here. The front view will be projected here. So what is the distance from the center axis? It is of distance 50 mm. It is of distance 50 mm. Okay. So from here will be, this is 50 mm. So absolutely this will be 50 mm. Now we are going to the top view. Top view of the point. So we can get the point in the HP. So top view of the point we can get in the projected to the HP. Okay. So what's the distance? The distance on the center axis is from here to here it is 30. Because this is already 30 mm. So obviously it will be 30 mm. Okay. So now we are going to draw the solution. Just leave 20 mm. Okay. Just leave 20 mm gap and you can solve this. This is the answer for first question. This is the answer for second question. Okay. So first we should draw the front view. So this is the front view. This is the front view. You can mark it as B dash. Am I right? So it is 50 mm. From here, draw a straight line or 50 mm. It should be 50 mm. So this is, since the front view, mark it as B dash. It is 50 mm from the reference line. It is 50 mm from the reference line. Okay, next let's see about the top view. Where the top view is, it is in the HP. So what is our condition for HP? The condition for HP is it rotates 90 degree clockwise. Okay, so consider this as the second quadrant. A point. Okay, this is the second quadrant. A point is 50 mm above HP and 30 mm behind BP. So a point is here. Okay, so we have got a front view, consider a front view in vertical plane, and top view is considered in HP. What happens to HP? HP rotates, so this is HP and this is VP. HP rotates 90 degree in clockwise direction. Okay, it rotates like this and overlap with vertical plane. So what happens? So our distance is 30 mm. What happens? It rotates 90 degree clockwise direction and gets overlapped with VP. Okay, so we will be getting a point here in the same line. Okay, what is the distance? The distance is 30 mm. Okay, the distance is 30 mm. So I draw extension line and mark it as 30. Okay, the point will be named as B. Since it's a top view, we are naming it as B. Okay, if it's a front view, we will be naming it as B dash. Now let's move on to our third question. A point C is 30 mm below HP and 40 mm behind BP. So below HP and behind BP, it corresponds to third quadrant. Okay, so let's trace our point here. 30 mm and 40. It's below 30 mm. Okay, point is C. It is below 30 mm and behind is 40 mm. Okay, behind is 40 mm. Okay, so in this one we will get our front view. The front view will be projected here. The front view will be projected here. Okay, so this is our front view. It will be named as C dash. Our top view of point will be projected here. Our top view of point will be projected here. So it will be named as, this is projected in HP. It will be named as C. Okay, so what is the distance? The distance from the center axis to C dash is 30 mm. The distance from center axis to top view is 40 mm. Clear? So now let's draw a diagram. So it is 30 mm. Okay, and what happens to HP here? What happens to HP? Similar condition. What happens to HP? So this will be your third quadrant. Okay, a point is projected here. Okay, so front view is projected in vertical plane, top view is projected in horizontal plane. Okay, what happens to HP? HP rotates 90 degree clockwise, so it will rotate like this. So we will be getting a top view in HP. Okay, so now let's see the answer. So this is our VP. So what I am going to do? I am going to draw a straight line. Okay, this will be our C dash. This will be our C dash. What is the dimension? Our dimension is 30. Okay. So HP rotates 90 degree clockwise direction. So we are getting a top view here. So this will be our. So this will be a straight line. I am trying to any scale or pencil. Okay. So this will be our C. That is top view. It is 40 mm. It is 40 mm. Clear? So it should be a straight line. Please make sure. And next go to the fourth question. A point D is 50 mm below HP and 25 mm in front of VP. Okay, below HP and in front of VP, it corresponds to fourth quadrant. Okay, it is 50 mm below HP and 25 mm in front of VP. So this is 50 mm and this is 25 mm. Okay. So now the front view will be projected here. The front view of point will be projected here. Okay, that is vertical plane. The top view will be projected in the horizontal plane. Okay. So since the front view, we can name it as, this is a point D. So we can name it as D dash. We can name this as top view. We can name this as D. Okay. So what is the distance from here to here? From D dash to center axis is, distance is 50. From D to center axis distance is 25. The distance of point from here to here is 25. So what happens to HP? HP rotates clockwise direction. Okay, again actually fourth quadrant. So this will be our fourth quadrant. Okay, fine. So this will be our fourth quadrant. Okay. So what happens to HP? HP rotates 90 degree clockwise. Okay. So this is our horizontal plane. This is our vertical plane. So when point is kept here, front view is projected in vertical plane and top view is projected in horizontal plane. So what happens to HP? It rotates clockwise 90 degree. Okay, if it rotates clockwise 90 degree, it overlaps with vertical plane. Okay. So what happens? Both the point will be in a single line. It gets overlapped. Okay. So at first I will draw the front view. The front view is D dash. It is 50 mm. So a line of 50 mm. It is D dash. It's a front view. Okay. So it is 50 mm. Okay. What happens to this top view? It gets overlapped. It is 25 mm. It comes in the same line. Okay. Measure 25 mm, and this will be our D. This will be our D, and it is top view. It is 25 mm. Clear? So this is our solution for all the 4 questions. This is third one, and this is fourth one. And end of the page, write all dimensions are in mm. All dimensions are in mm. Okay, that is millimeter. So if you see, we are going to use only first quadrant and third quadrant. You see, there are 4 quadrants: first quadrant, second quadrant, third quadrant, and fourth quadrant. So in this we are using only first quadrant. So it is called as first angle of projection. Okay, where front view is projected in vertical plane and top view is projected in horizontal plane. If you see, Americans they generally use third angle of projection. That is third quadrant, where the top view will be projected in horizontal plane and front view will be projected in vertical plane. Okay, as per the third quadrant condition. These second quadrant and fourth quadrant are not being used because these 2 quadrants overlap with each other. Okay, so we are not able to get the views properly. We are not able to get the views since it gets overlapped. So we are not using second quadrant and fourth quadrant. Okay, so this is about the projection of points. Thank you.